Part 2 starts from here. Now the next question. In that we have to prove that tan A plus secant A minus 1 upon tan A minus secant A plus 1 is equal to 1 plus sine A upon cos. Now this question will be solved using the following steps. That is, the first step is to convert it into sine and cos form. Again, for this we have two methods, so I would be solving both the methods. In the first method we need to convert it into the basic form, that is sine and cos form. So tan A can be written as sine A upon cos A, and secant A can be written as 1 upon cos A minus 1. And in the denominator, again we can write this as sine A upon cos A minus 1 upon cos A plus 1. Now the second step is to take the LCM in the numerator as well as in the denominator. In the numerator we have the LCM as cos A, and it will become sine A plus 1 minus cos A, and in the denominator also we have the same LCM as it cos A, and the numerator will become sine A minus 1 plus cos A. Now we will take the reciprocal of the denominator. There are two ways. You can cancel this and this directly, or you can do one more step of writing the denominator in the reciprocal manner. So I'm going to do that, and then I'm going to cancel this cos A and cos A. So the numerator will remain same, and the denominator will be written as cos A upon sine A minus 1 plus cos A. So now these two will get cancelled. So we are left with sine A plus 1 minus cos A in the numerator, and sine A minus 1 plus cos A in the denominator. Now still the left hand side is not equal to the right hand side, and we only want 1 plus sine A in the numerator and cos A in the denominator. So now what I'm going to do, I'm going to rationalize the denominator. Now I'm going to multiply the numerator as well as the denominator with 1 plus sine A, or you can say multiplying and dividing by 1 plus sine A. So here I am writing 1 plus sine A in the numerator and 1 plus sine A in the denominator. So now the numerator will become sine A plus 1 minus cos A into 1 plus sine A, and here I am going to multiply these two denominators. Means first of all I'm going to multiply 1 with sine A minus 1 plus cos A. So it will become sine A minus 1 plus cos A. Now on multiplying sine A with sine A, we will get sine square A, and on multiplying sine A with minus 1, I will get minus sine A, and on multiplying sine A with cos A, I will get sine A into cos A. Now this sine A and sine A will get cancelled, and we are left with minus 1 plus cos A plus sine square A plus sine A into cos A. Again, it's very complicated, so what I'm going to do now, as in the denominator we just want cos A, so I'm going to substitute the value of sine square A from the first identity, that is sine square theta plus cos square theta is equal to 1. We know that sine square theta plus cos square theta is equals to 1. So I can substitute the value of sine square theta as 1 minus cos square theta. So now the denominator will become minus 1 plus cos A plus 1 minus cos square A plus sine A into cos A. This negative 1 and plus 1 will get cancelled out, and left with cos A minus cos square A plus sine A into cos A. Now from the denominator I am going to take cos A common, and let's see what we get. So now on taking cos A as common, I am left with 1 minus cos A plus sine A. So if you see clearly here, the numerator has sine A plus 1 minus cos A. Even the denominator has sine A plus cos A plus 1. So we can cancel out these two and we are left with 1 plus sine A upon cos A, which is equal to the right hand side. So the left hand side is equal to the right hand side, hence proved. Now I will be using the second method for solving the left hand side equal to right hand side. This is a shorter method, but it requires just one technique to solve it. Again, I would be solving the left hand side. Now we know that there is one identity, that is secant square theta minus tan square theta is equal to 1, which connects secant square theta and tan square theta. So what I'm going to do now, here in the numerator only, I will be substituting the value of 1 as secant square theta minus tan square theta. So it will become tan A plus secant A minus secant square A minus tan square A, and the denominator will remain same. We are not going to touch the denominator, so it will be tan A minus secant A plus 1. Now if you see here, you consider secant square A as A square and tan square A as B square. So we can apply this identity of A plus B into A minus B, because A plus B into A minus B is equal to A square minus B square. So I'm going to apply this formula here in the numerator and let's see what we get. So we will get secant A plus tan A into secant A minus tan A, and the denominator will remain same. Now from the numerator we can take tan A plus secant A common from both the terms. So I'm taking tan A plus secant A common from both the terms. We are left with 1 minus secant A plus tan A, because this has been taken common. So if I see this negative here and this is secant A, so it will become minus secant A, and here again we have negative and we have here minus tan A, so this will become plus tan A, and the denominator will remain same, that is tan A minus secant A plus 1. So if you compare the numerator and the denominator, these two terms are same and they will cancel out. So we are just left with tan A plus secant A in the numerator. So now this is what we have on the left hand side, but still it is not equal to the right hand side. So I'm going to break it down into the basic, that is tan A can be written as sine A upon cos A, and secant A can be written as 1 upon cos A. So now if we combine the denominator, that is cos A, we will get sine A plus 1, which is equal to 1 plus sine A upon cos A in the right hand side. So the left hand side is equal to right hand side, hence proved. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.